All right, so in this video, man, we're talking about one of the OGs in the game, right? One of the OGs, I like to call them the OGs when they got 10 plus or more years in the game as far as telescopes or probes go, right? You got your Voyagers, you got your Junos, you got your, you know what I mean? When they got 10 plus, I like to call them the OGs. So today we're talking about the Juno probe, right? NASA has just announced that Jupiter's moon, Io, has started to send the Juno probe messages. Now, if you remember, one of the videos talked about when the Juno probe launched, I want to say it was 2012-ish, 10, 11-ish, around that time, right? But what fascinated me, it's caught my attention because I was still just learning about them, was the speed at the time. I was like 165,000 miles per hour, bro. Just insane for my mind to even fathom that type of speed coming into the game, learning about this stuff. All right, so we're gonna check this video out, man. If you're new, you know what to do. Hit that subscribe button, join the fam. Let's check it out.
Scientists are making exciting discoveries at an astonishing rate, and it can be nearly impossible to keep up with all the news.
True.
So today, here at Unexplained Mysteries, we will be looking at 3 of the most fascinating scientific discoveries that you might have missed. NASA just announced Jupiter's moon Io is sending the Juno probe strange radio waves. Jupiter holds the largest and most powerful magnetic field out of all the planets in our solar system. The field is about 20,000 times stronger than Earth's, partially due to the solar wind that batters Jupiter with electrically charged particles that blow from the Sun. Jupiter's magnetic field extends so far that several of its moons orbit within it. The planet's closest moon is named Io, and it is constantly caught in what NASA describes as a gravitational tug back and forth between Jupiter and 2 neighboring large moons. This tug game generates internal heat, which causes hundreds of volcanic eruptions on the surface of Io, which is home to over 400 active volcanoes. For this reason, NASA has deemed Io as the most volcanically active world in the solar system. The moon's
Can you imagine that? The tug back and forth causing all of this. That's why it's important we stay where we are, bro. Imagine getting off course and getting caught up in something like that, man. And now you got to deal with active volcanoes on a regular. Like, man, we got a lot to be thankful for, bro. I'm just saying.
As the most volcanically active world in the solar system.
Wow.
The moon's volcanoes release particles into space at a rate of 1 ton per second. When some of the particles split, a shower of ions and electrons enter Jupiter's magnetic field. Electrons are then pulled to Jupiter's pole, a process which emits decameter radio waves. Now, NASA is sending its Juno spacecraft to listen to Io's radio waves and hopefully help us understand the strange phenomenon. To detect the radio emissions, the spacecraft has to be in a precise location. Using data from Juno, the research team was able to determine exactly where the radio waves are generated, based on conditions relating to the strength of the magnetic field and the electron density. They discovered that the waves come from what seemed to be a rotating hollow cone. Juno receives the cone's signal only when it rotates in line with the spacecraft. NASA compares this to a lighthouse beacon shining on a ship. Researchers were surprised when data from Juno indicated that the radio waves emit 23 times more energy than expected. However, this is influenced by Jupiter's magnetic field and solar wind. These findings are helping scientists understand the behavior of Jupiter's large magnetic field, and we will likely hear of more discoveries from the planet in the near future.
Didn't they say also, though, that Jupiter's magnetic field also protects us because of the things it's able to, you know what I mean, stop from coming our way? So we can't all the way around. If that's the case, we can't be mad at it. You know what I mean? We need it.
The Sun to have Saturn-like rings. There is a type of planet called a super-Earth, and if you were living there, you have the rings of the sun to blame. Recent simulations suggest that Saturn-like dust rings around the sun prevented our planet from ever reaching super status. A super-Earth is a planet that shares Earth's rocky surface, atmosphere, and water-favoring conditions, but is twice the size of our planet.
Wow.
Astronomers have previously found super-Earths within 30% of the Milky Way's solar systems. In order to investigate the lack of a super-Earth in our own solar system, astrophysicist Andrei Isidoro and a team of other scientists created supercomputer simulation models of our solar system's formation. The team ran hundreds of simulations before finding one that aligned with our solar system in the present day. The version that most accurately predicted important features like asteroid belts, planetary masses, asteroids, and more also involved rings around the sun in its early stages. It suggested that it was these solar rings that limited the mass of Earth. In the model, 3 high-pressure regions, called pressure bumps, of dust and gas form around the young sun. This is likely due to the sun's strong gravitational pull acting on particles that then heat up and release gas. The distinct bumps seem to form on sublimation lines, which are areas where certain particles are vaporized. These pressure bumps accumulated particles, which prevented them from being pulled all the way into the sun. Eventually, the gas and dust cooled, and the sublimation lines moved closer to the sun. Through this process, dust assembled into planetesimals, which are the seeds for planets. According to Isidoro, our model shows pressure bumps can concentrate dust, and moving pressure bumps can act as planetesimal factories. The researchers theorized that because of the pressure bumps, the sun did not have a smooth protoplanetary disk, which allowed bits of dust to accumulate rather than be swallowed by the sun. The bumps also affected the amount of material available to form planets. Isidoro stated, "We propose that pressure bumps produced disconnected reservoirs of disk material in the inner and outer solar system and regulated how much material was available to grow planets in the inner solar system." Isidoro's simulation showed that the ring closest to the sun may have formed planets in the solar system. The middle ring formed the planets of the outer solar system, while the ring furthest from the sun formed comets and asteroids beyond Neptune in the Kuiper Belt. When the research team delayed the formation of the middle ring...
I'm still stuck on grow planets, bro. Like, space is just different. And the things that happen out there, it just still continues to be jaw-dropping, bro, when you think about it. Like, grow planets? Have we ever paid attention to the rings like that on anything? And now we're hearing that they can actually do that. Man, please, bro. Like, if you're gonna find this fascinating, bro, check your pulse.
System, while the ring furthest from the sun formed comets and asteroids beyond Neptune in the Kuiper Belt. When the research team delayed the formation of the middle ring in the simulation, it showed super-Earths developing in our solar system. They suspect that the timing of the middle pressure bump was a crucial element of the evolution of our solar system. This research is not the first to assume concentrated dust could form planetesimals. The team's simulation is the only model that provides a logical explanation for how the dust might accumulate. Although the study is based more so on a model than concrete evidence, the findings are still extremely valuable because they suggest a new and highly plausible explanation for how our planet came to be. A mysterious glow warms rings of Uranus. Believe it or not, a temperature reading minus 320 degrees Fahrenheit suggests a heat wave surrounds Uranus. This temperature, which is the boiling point of liquid nitrogen, was detected within the rings of Uranus by heat images recently produced by 2 massive telescopes in the deserts of Chile. As minus 320 degrees certainly is not warm from an earthly perspective, it is significantly hotter than much of space. Space gets so cold that it nears absolute zero, or minus 460 degrees Fahrenheit, which is the temperature at which atoms stop moving.
That's another thing I always forget about too, the temperature in space. You know what I mean? I don't never think about that. I think about the planet's temperature, but just the actual temperature of space. I always forget to think about that, man. You know what I mean? So now I'm thinking about that. You think about those suits that the astronauts have to wear to be able to step out of a spacecraft, like on the moon or something, what temperatures that they have to possibly endure. You know what I mean? Like, or just being out in space, period, whether they're working on the aircraft that, or the spacecraft they're in, you know what I mean? And something goes wrong with it, they have to get out there and physically try to fix it. And being out in that temperature and that, I forget to think about that, bro. It's so many different layers of elements to worry about being there.
160 degrees Fahrenheit, which is the temperature at which atoms stop moving. So, relatively, a wave of minus 320 degrees can be considered quite warm. The discovery of a heat wave around the Uranian rings surprised scientists, since Uranus orbits far out in the solar system and does not receive nearly as much heat from the sun as we do on Earth. Scientists are unsure what is causing the warm glow shown in the heat images, but they are adding it to the list of reasons why the rings of Uranus are so unique, especially the Epsilon ring. The Epsilon ring is the planet's brightest, widest, and densest ring. Unlike the rings of Saturn, which are made from both microscopic and meters-long particles, the rings of Uranus do not contain tiny particles. The Epsilon ring is made of rocks the size of golf balls or larger. Uranus's rings also reflect less light than Saturn's and are narrower. The Epsilon ring measures up to 100 kilometers wide. Saturn's rings measure up to tens of thousands of kilometers. Because Uranian rings are darker, extremely large telescopes are required to spot them, and they were not discovered until 1977. Astronomers hope to learn more about the mysterious composition of the rings. It is possible that smaller material is merging together or something is pulling it out. Scientists are also eager to learn if the source material is the same or different for all of the rings. Rings can be formed through a variety of processes. Sometimes they are created from asteroids brought in by the planet's gravity, and other times they are formed from moon remnants. Future studies are needed to further unpack the unique qualities of the rings of Uranus. But what do you make of these recent discoveries? Be sure to let us know your thoughts in the comment section below and help us by growing this community while working to solve these unexplained mysteries. Thank you for watching, and don't forget to subscribe for more videos.
Like, I never really paid attention. Like, each video you learn something new, but often, every now and again you come across a video where you've noticed something, but it makes you pay attention to it even more. Like the rings around Saturn, or you just knew they were there and they had some significance, but you didn't really know the importance of it. Now look at you, and look what it does, and look what you've learned from it. Y'all get at me in the comment section, man. Let me know what you think, and stick around and stay tuned. Next one, I'm gone. Peace.